stop kan. So kita lepas tu we will continue to third properties and transitive. Okay, transitive. Okay. So transitive relation are on a set A, we can call this transitive if for A, B, C is element of the set A. Okay, which is A, B is element of the relation and B, C is element of the relation and implies A, C is element to relation, which is kalau transitive, if we have a transitive, so it would be AC. Okay, the result will be AC, element of the relation. Okay, contoh ya, I give you the example here. Okay, and show that which one the relation is a transitive. Okay, give we I give you the three R2, R3 and R4. Okay, so kita kena tengoklah. We can see one by one. Is it the R2 is transitive or not? R3 is transitive or not? And then R4 is a transitive or not? Okay, look at the first, the R2. Okay, I mentioned here is not transitive because okay, one is actually is a relative kan, D is a reflexive. Okay, so 1 2, okay, look at this, 1 2, okay, 2 1. So would be 1 1. Okay, so adalah this is a correct the answer. But if we taking for the 2 1, suppose we have a 1 okay, 2 1, so another one we taking the 1 2 here, and the result will be can be implied as a 2 2. But in the relation 2, we don't have element of 2 2 here, so we can say is not transitive. Even we have a 1 1 1 2 and 2 1 also is element of the R2, but we don't have a 2 2 to declare this statement. So we can say this is a not transitive. Okay? Any question? Is it clear?
Clear, Doctor.
Okay. So we go further for the R3, relation 3. Okay, you look at this one. For relation 3, okay, I give you 1 minute. You think R3 is a relative or not? Okay, here we have a 1 1, 2 2. Okay, D is a 2 2, 3 3 and 4 4 here. Okay, so D is a reflexive. So we look at the other element is a 1 2. Suppose 1 2, which is we have a 2 1 2, another 2. Okay, if we're taking the 2 1, suppose we have the result or implies to 1 to 1. So we have here. Okay, and then if we taking for the 1 2, okay, we another one is a 2 here, 2 2. Okay, suppose the result will be 1 2. Okay, 1 2 only we have element of the R3 also. So is it this is okay, this is okay. Okay, another one we go, okay, 1, 2. 2 tak ada dah kan? Okay. So we go for the 1, 1, 4. 1, 4. So we got it the 4, 1. So we can implies the 1, 1. So we got it here. Okay. 1, 4. Another one? 4, 4 kan? 1, 4, 4, 4. So we have the implies the 1, 4. So ada kat sini kan? Okay. So another one is a 2, 1. Okay, look at this. 2, 1 will be 1. 1 what? 1, 1. Okay, 1, 1 tak boleh. Dia still 2, 1 jugalah. Okay, sama kan? Okay. This okay. Okay, 2, 1. Another one. 2, 1. 2, 1. And 1, 2. Implies the 2, 2. Okay, ada tak 2, 2? 2, 2 ada juga. Okay. And okay. So another one. 2, 1 lagi. 2, 1. And what is it? 1, 4. Okay. 1, 4. So we have a 2, 4. 2, 4. Ada tak? Is it here? 2, 4? 2, 4.
Tak ada.
Tak ada kan? So we don't have a 2, 4. So meaning that kalau satu pun tak ada, which is kita can declare this is a not transitive. Okay? So you can checking one by one lah to show that this is a transitive or not. Once that is not certified, so all the relation is not transitive. Okay, go on. R3 is not transitive because only 2, 1 and 1, 4, suppose with the result will be 2, 4, is not element on the R3 ni. Tak ada pun. We don't have element 2, 4 in R3. So, we can say this is a not transitive. Okay? Okay. Ni bukan, so R2 is not transitive, R3 also not transitive. Okay, we look at for the R4. R4 macam mana pula? Okay. So, 2, 1, 1, 2, 1. Okay, if we taking the 2, 1, okay, we don't have a 1 here in the beginning. So, we taking the 3, 1. Okay, 3, 1. 1, 3 also. Okay, we started from the 3, 2 actually. Okay, 3, 2. Okay, and 2, 1. So suppose we have the implies the 3, 1. Okay, ada kan? Here. And then we go 3, 3, 2. Tak ada dah. Okay, so we go for the 4, 1. 4, 1. Okay, you look at the 1. Okay, so tak ada juga kan? We don't have a 1. Started from the 1 here. So we go for the 4, 2. 4, 2. Okay, we have a 2, 1 here. So it can be implies and 4, 1. Okay, 4, 1 we have a 4, 1 in the R4. Okay. So next 4, 2. Okay, ada tak tu lagi? Don't have a 4, 2. So we go for the 4, 3 pula. Ini semua dah ada pakai kan? Okay. So we go the 4, 3. Suppose we have a 3 started here and we look at this is 3, 1. So it can be implies 4, 1 here. So we got it the 4, 1 here. So semua is a certified.
Binary
and
relation.
Semua ada in the element for the R3. So we can say R4 is a transitive.
Penatnya.
Boleh? Anyone?
Boleh, Doktor.
Okay, so don't forget to stay attended at Putra Plus, okay? Before I forget to inform you. Okay, So I hope you understand. Okay, you can actually you can check every the element to show whether this is a certified or not, or this is a element of the relation or not. Alright. So uh, so I already give you an example in terms of the symmetric, reflexive, and also for the transitive. Okay. So kalaulah if the all the properties is certified, which is R is certified for the reflexive, symmetry, and transitive, we can say binary relation R on the set A, we can call this a equivalent relation. Okay? Kalau dia certified all the reflexive, symmetry, and transitive. Okay? We can say this is a equivalent relation. Okay, andai if one of the property is not certified, which is kalau lah misal kata reflexive is not certified, let's say. Okay, so all the binary relation is not equivalent relation. Walaupun satu, even one pun yang tak certified in term of either symmetric or transitive not certified, kita cakap is a not equivalent relation. Dia mesti semua all certified, barulah we can say this is a equivalent relation.
Roti Milo.
Okay? So dia ulang balik. A relation R on the set A is called
Intan
equivalent
kan?
relation if the
tapi Milo.
reflexive, symmetry, and
Kan?
transitive
Tak lah.
certified lah.
Nasi.
Okay? So example, okay, LR be the relation on the set of the integer such that we can say A relation to B if only A, maybe A equal to B, also A equal to negative B. So we can say R is equivalent relation also. Okay? Ataupun we can say if A subtract the A, so we can say also this is a equivalent relation. This is an example only. Just the example. Okay, the actual example, and if I give you the statement here, okay, this one. Okay, you must show this statement equivalent relation on Z. So discuss your answer. Okay, to show the equivalent relation, you may show that the equation the problem must be certified and reflexive, symmetric, and also the transitive. So kita kena buat one by one to show that. Okay. So you must show the tilde is a reflexive. Okay. So you taking just only norm A equal to norm X if tilde X. Okay, maksudnya we can say we can substitute Y to X here. So the tilde is a reflexive. Just show that je. Sebab kita tahu bahawa A, B will be AB also. This is a reflexive. Okay, to show this is a symmetric, which is AB must be BA. Okay, so just you put it the X tilde Y if the X norm X equal to norm Y, or we can say norm Y equal to norm X. Just change the position. Sure to be the XY, to be the YX. So we can say this is a symmetric. Okay, for the transitive, you must show A, B, B, C. So can be implies A and C here. Okay, so you show only X tilde Y and Y tilde Z. Suppose the result will be XZ. So if X equal to Y and norm Y equal to norm Z, so will be norm X equal to norm Z. So is a negation Z. So tilde is a transitive. Okay? So you can show every the form is a reflexive, symmetric, and transitive. Okay, if the three properties is satisfied, so we can declare this is a equivalent relation. Okay, another one. Okay, kita look at another example here. Okay, okay. The problem here is x star y implies x less than greatest than y. So does the relation satisfy reflexive symmetry and transitive law? So discuss your answer. Okay, so you must show one by one. Okay, first thing you show this is a reflexive or not. Okay, so x greatest than x. Okay, for example, kalau if we take any number here, 2 is a greatest than 2. So suppose is a not reflexive lah, dia tak not true kan ni. 2 lebih besar daripada 2. So this is a not true. Show that this is a not reflexive. Okay, kalau if you want to do show the example, uh, you can give the example if can. Okay, for the symmetric, for the second condition, second properties to show this is a symmetric, okay, you look at x greater than y to be the y greatest than x. Is it true? Okay, you can take any number. 2 greatest than 1, this is a true, but 1 is a greatest than 2. Kalau kita change the position, it's not same. It's not same, and this one is true, this one is not true. This is a wrong. So we can say this is a not symmetric. Okay, you can give the example if can. Okay, the third properties to show this is a transitive. Okay, so the transitive x greatest than y. Okay, this is a greatest than y, and y is greatest than z. Maksudnya y is a sorry. Sini kan. So x is a greatest than z, implies x the greatest than z. Betul lah kan? Okay, contoh kalau I give you the example, contoh I want to take 2 for this one, this is a x, this is a y. So if I want to do the 1, y greatest than z, so 1 and 0. So betul tak? X dengan Z lebih besar and greatest than Z. So which is 2 is greatest than 0. This is a true. Okay? So we can say this is a transitive. Okay. So we can say if you want to discuss your answer, so this is not reflective, not symmetric. So we have two property is satisfied, only the transitive is satisfied, so we can say this is a not equivalent relation. Alright. Okay, secara kita boleh rumuskan, or we can conclude that, okay, and if we have a set A, so if we want to show that is a reflexive, so dia jadi dirinya in self sendirilah. Okay, if we have a two set, okay, to show this is a symmetric, so A to be the B, and also B can be to A. So this is a case for the symmetrics. Okay, and then the third properties, okay, we have a three set here, okay, from the A to the B and B to the C, and can be implies directly A to the C. Okay, so this is a process for the transitive. Okay, so so take note here. An equivalent is not certified when one of the reflexive, symmetric and transitive property is not certified. Kalau satu pun tak boleh, kalau tak not certified. Make sure must be certified all the properties. Reflexive, symmetric and transitive must be certified. And barulah we can say this is a equivalent relation. Okay. Kita tengok lagi contoh. Binary relation between the set A and B is a set of the Cartesian product A, Cartesian B. So if we say A equal to B, which is an element A must be same with the element B. Okay. Suppose that, okay, A is a 1, 3, 5, 7. 1, 3, 5, 7. Okay. So 1, 3, 5, 7. And the element B, we have a 2, 4, 6, 8. So A equal to B maksudnya D is from the element A. Okay. And then D is from element B. So the dot, the black dot. Okay. The black dot is an A equal to B. So we can say this is a 1, 2, 3, 4, 5, 6, and 7, 8. This is a relation to show this is a relation, or we can written as S. This is a subset A Cartesian B, so binary relation between the A and B, axis X to axis B. Okay, kalau let's say A is less than B, so the diagram can be show this one. Dia lebih besar daripada B kan. So the dot is a relation between the set A and B, only the black dot. Okay. Because we mentioned one set before another in a Cartesian product, A Cartesian B, the element AB is any relation R over the A and B must have its first element, okay, must be from the first element to come from A, and the second element to must be come from B. Okay, so we have a pairing here. Ni element from the A, ni element from the B. So we can say this is a order 4 or pairing for this element. Okay, ini ada beberapa lagi example here. You can do it, and or you can do through your tutorial kan. Kalau nak bagi ada lagi soalan lebih, you can do lah example ni. Okay. Kalau nak snap gambar boleh snap dan try buat. Okay. So kita pergi sikit lagi lah. Okay, fractional and rational. Okay, question here. Okay, R1 over 2, 2 over 4, 3 over 6, 4 over X, 5 over 10, the same or different? What you think?
Same. Same.
Same.
Yes, same.
Okay. Actually, in term of the symbol, they are different. Okay, betul lah different kan? 1 over 2, 2 over 4, this is a different symbol. But in term for the same, for the rational number, this is a same. Okay? So, itulah maksudnya. Kalau you thinking about this, kita boleh cakap ataupun algebraize ataupun orang-orang algebras dia cakap maybe sama tapi tak serupa macam itulah. So what we can do itu in term of the word equivalent tu. Alright. So macam ni jugalah the basically when we look at the illustration from this picture, give the three lion ya. We see the three lion here. Or we can terjemahkan ataupun we can represent as ada three lion bentuk macam tu. Okay? Equivalent. Kita boleh cakap ini adalah equivalent. Dia sama tapi tak serupa. Macam itulah dalam word. Malay word. Okay? Okay, so in term of the familiar equivalent relation, selalunya for the arithmetic, we can use the symbol equal, symbol greatest and greatest that less than and equal, also the greatest than and equal, ataupun if the logic, and we can say this is if and only if. Okay, so in this section, just to give you noted, yeah, must be carefully to define every denotation of the equivalent relation, and then you can show lah, you must show selalunya equivalent relation to give the rise to equivalent classes, okay, tapi kita tak masuk pun equivalent classes ni, kita only the equivalent relation, okay. Dan ada obtain the important example from the equivalent relation. Okay, ni just dah habis lah sebenarnya. Okay, just giving your recall your memory again. A relation of the set A is called equivalent relation if the three properties is satisfied, which is reflexive, symmetric, and transitive. So two elements related by equivalent relation are called equivalents. Okay, ni tak ada, dah sama tadi. So we can say if we have a order pair in element of the S, so A pairing the AA element of the R, we can say this is reflexive, and AB can be implies to be A. So we can call this symmetric. Also the last one is we have a two AB and BC can implies to AC. So this give transitive. Ataupun dalam yang saya bagi sebelum ni, the figure tentang ini kan, saya urang balik lah. It's a reflexive, this is a symmetric, and then this is a transitive. Okay, so ini sama je dia ulang balik. Saya okay, ini pun kalau using the tilde simbol the tilde tu, we can show jugalah this is a reflexive. So don't you jangan terkejut lah if we show ada tilde here. So you can show if give the tilde symbol the tilde. Okay, symmetric A tilde B will be B tilde A, and also the transitive A tilde B and B tilde C can be implied A tilde C. Okay. Okay, ataupun in is equality can be show that is equivalent relation. Okay, boleh juga ya. Kalau A equal to A, kita boleh show this is a equivalent relation. A equal to A for IRX for in term of the reflexive, and A equal to B implies the B equal to A. This is a symmetric, and also A equal to B, and if we have a B equal to C can be implies A equal to C also. So all three property is certified. So equality Equality, this one is show is a reflexive, symmetry and transitive. Okay, equality pun boleh juga untuk show that is a equivalent and relation. Okay. Is it the less than and equal or greatest than equal can represent the is a equivalent relation or not? Boleh tak? Okay. Macam tadi kan kalau ada lebih besar, lebih kecil, I already give you the example before this. So we make, if we taking the any number here and give the example, so one greatest that less than and equal, but two is a greatest than equal. So less than and equal is not symmetric. Dia tak boleh beri kan? Tak beri that is the same. This is a true. This is not true. So greatest than and equal is not equivalent. Dia tak boleh show that this is a equivalent relation. But equal boleh, can be, to be the equivalent relation. Okay. Okay, ini pun ada give the example here. Okay, R1 is not reflexive. So kat sini we don't have a element of the 1 is not element the R1 in the R1. So this is a not reflexive lah. Okay, for the in term of the symmetric, it give the symmetric. Also, but for the in term of the transitive, 1, 2 to 1, suppose we have a 1, 1 here. Okay, so in this R1, we don't have a 1, 1. So it's a not transitive. Macam tadi lah saya terang. Ini tak nak pergi. Kita tengok another example here. Okay, before we break, before we finish it. Okay. We have a 0, 1, 2, 3 equivalent relation. Okay. Let's try to 0, 0, 1, 1, 2, 2 and 3, 3. Has all the properties. Adakah ini equivalent relation? Is it this is a equivalent relation or not? This is show about the 1, 1 kan?
No.
1, 1 kan? This is show about the reflexive, symmetric, same sir. So dia semua certified. If you do the equivalent relation in term of the reflexive, symmetric and also for in term of the transitive. Semua certified. Okay, another one. Okay, cuba you look at this. So reflexive sini 0, 0, 2, 2 ada, 3, 3 ada, but we have missing the 1, 1 only. So it's not reflexive. Also in term of the transitive, we don't have a 0, 2 and 2. Okay, we have a 0, 2 here, 0, 2, suppose 2, 3. So the can be implies 0, 3. But 0, 3 is not here. Okay, it's not here. So it's a not transitive. Okay, yang ini pula. So yang ini, this is a equivalent relation. Because we have a 0, 0, 1, 1, 2, 2 and 3, 3. This show about the reflexive. And in term of the symmetrics, 1, 2, 2, 1 to be the 1, 1. Okay, ada. Okay, so this is a reflexive. And in term of the transitive, okay, 1, 2, 1, 2, 2, 2. So we have a 1, 1, 2, 1, 2, 2. Tak boleh kan? 1, 2. Okay, sorry. 1, 2. 2, 1. Ini refleksif. Ini symmetric. Okay. Transitive. 1, 2, 2, 2. So we got it the 1, 2. Okay. Ni ada transitive. Okay. Yang D. D in term of the reflexive. 0, 0, 1, 1, 2, 2, 3, 3. Okay, betul. Is correct. In term of the reflex and in term of the symmetric. Okay, 1, 3. Suppose we have a 3, 1. So we got it the 1, 1. Okay, ada 2, 3, 3, 2, 3, 3, 2. So 2, 2 ada. Okay, 3, 2. Suppose we have a 2, 3. So 3, 3. We got it here. Okay. Transitive. Okay, in term of the transitive. 1, 3. Okay, you can do the one by one lah. Okay, I see here 1, 3 and 1, 3. Suppose we have a 3 here. 3, 2. But we don't have a 1, 2 here. Ada tak 1, 2? Ada kan? So this is a not transitive.
Doktor,
Mm-hmm.
boleh tak bagi ulang balik yang A tu transitif untuk A? Kenapa? Macam mana nak tahu transitif untuk A tu?
Okay, kalau A tu we have actually 0, 0, 1, 1, 2, 2, 3, 3 ni dia is in-safe kan. Semua dia memenuhi semua ni. So dia memang equivalent relation. Kalau kita buat 2, 2 dia tak boleh terbalik pun kan. 2, 2, kita buat 2, 2 dia change the position is the same. Alright, so sama je semua. So dia semuanya certified for 3 term tu. Okay?
Okay.
Okay, the last one E. Okay, kosong. Okay, kita tengok transitive ya. Kita tengok reflexive. Ada 0, 0, 1, 1, 2, 2 and 3, 3. Okay? Okay, so this is a certified in term of the reflexive. Okay, symmetric. Okay, 0, 1. Ada tak 1? 1, 0. Okay, 0, 1. Sekejap, saya pakai 0, 1. 0, 1, 1, 0. Suppose started from the 1, 1, 0. So we got it the, we got it the 0, 1, 1, 0. Okay, 0, 2, 2, 0. 1, 0, 1, 0, 0, 1. Ada kan? Okay, ni 1, 2. 1, 2, suppose we have a 2, 1. Tak ada 2, 1 here. We don't have a 2, 1 here. So 1, 2 present here, but 2, 1 is not here. So show that is a not symmetric. Okay, satu je dah tak ada, so tak payah buat yang lain dah. Awak dah nampak. If you see the one is not certified, so you don't check everyone. Okay, you just show why you say this is a not reflexive or not transitive or not symmetric. You show, you give the reason. You have the element is not element of this element R. Okay, kalau satu je tak ada, show, tunjuk je kat situ tak ada. Alright? So, in term of the transitive.
Doktor. So maksudnya kita tak perlu cari kan symmetric kan dah tak ada.
Okay, kena cari. Okay,
Cari
tapi,
lagi yang sensitif.
okay, kena cari. Okay, satu mulut kena cari. Tapi kalau satu je awak dah dapat, so tak payah nak cari semualah. Tapi awak kena beritahu lah yang 0, 1 tu tak symmetric dengan 1, 2 tu. Faham? Kalau satu je dah jumpa yang tak certified, boleh tunjuk je kat situ. So tak perlu nak cari yang lain. Okay? Arina? Arina yang Jasmine kan tadi yang beritahu saya.
Okey doktor. Clear.
Okay. Not transitive. In term of the transitive lah. Okay, transitive mesti ada we have a 2 element and implies the result. Okay. So dekat sini kita tengoklah 0, 0 tak boleh kan. 0, 1. Okay, 0, 1. 1, 1. So 0, 1. Okay, ada dah ni kan. 01 to be the 11. So the result will be 01. 01 juga. 02 and to be the 20. So 00 ada. We don't have. We have. Okay, 100. Ada tak 001? So 11 we have here. Okay. Okay, 0100. So we have a 10. Sama juga. Okay, 11 kita tak payah tengok. 12. 12 suppose we started from the 2. So 20. So 10. 10 we have here. Okay, 12. 12. 12 suppose to 2 kan? So we have a 1, 2. 1, 2 juga. Okay, so we have here 20. 20. Okay, so the first partner is must be 0 lah. 20. 00. So 20 juga. Okay, ada lagi ni. 20, we have another one. 01. Suppose we have a 21. 21 here. No kan? Tak ada kan? Ada ke? 2, 21. Ada tak 21 here? Tak ada. So this is a not transitive. Okay. So tak payah buat yang lain dah sebab kita dah we only got it the one reason why we say this is a not transitive. So stop it. So we can say you just give the comment and give the reason why you say this is a not transitive. 20 and 01. Suppose the can be implies to 1, but 1 is not element of this relation. So yang ini transitive, yang ini equivalent relation, yang B is not equivalent relation. Equivalent relation C, D and E is not equivalent relation. Okay? Any question? Ada nak tanya? Tak ada? Okay, kalau tak ada, if you don't have any question, so officially we finish about the chapter 3. Okay, so we already learned about the chapter 1, chapter 2 and chapter 3. So for your information, chapter 1, chapter 2 and chapter 3 will be cover in your test 1 or assessment 1. Okay?
Doktor, boleh tak confirmkan balik tarikh assessment 1?
Tarikh 17 sekejap 17/11 actually 17 November. 17 hari bulan 11. 17 November. Actually next week. Next week on Wednesday in class. 11 until 12. Waktu ni lah. Minggu depan hari Rabu. Waktu kelas. Okay, so we have a test 1. Cover chapter 1 until chapter 3. Only the 1 hour and we can do the quiz pula. The test on the Google Meet jugalah. Okay, saya nak awak open your camera and saya akan guide melalui situ. Okay, so don't forget your test 1 next week on Wednesday in time dia 11 until 12. Waktu kelas lah, in the class time. Okay, chapter cover is chapter 1 until chapter 3. Okay, so next week we can go further for the chapter 4 on the Monday. Okay, everyone.
Thank you, Doktor.
Okay, terima kasih semua. Assalamualaikum. Thank you. And please stay attendant. tak buat lagi if they attended at the Putra Blast before 12.
Thank you, Doktor.
Okay, sama.